Hi, welcome to AP Calculus BC and your first flipped classroom video. This is video 8.1a. I will number them all. Your video notes should also say exactly that. Let me actually change that to 8.1, not to confuse you. We're going to be starting with integration review. So it is the only thing we're doing this year that is review, but I will tell you that it's a lot. So before we go any further, video notes, you should have a spiral notebook for your video notes and your class problem sets. So please have that with you. You're going to have to label your video notes. In this case, it would be video notes for 8.1a. Write down all new formulas, theorems, and definitions. Write down the detailed solution to one video problem of each different type. And of course, you can pause and rewind at will. You're going to want these to be very complete notes, both to earn full credit and because that's all you're going to have at your disposal to use when you're doing the problem sets and the quick polls. So we're starting with Chapter 8, Integration Techniques, L'Hopital's Rule, which you know well, and improper integrals, which we'll get to later. We're starting with Section 8.1, Basic Integration Rules. So on page 522, you'll notice this very long list of 20 different integration formulas. So in this case, A is a constant, as is K. So the first rule, of course, is just the ability, if you have a constant multiplying the rest of your integrand, you can pull out that constant. You can break up a sum or difference in the integrand. The integral of 1 du is u. Don't forget the plus c. This is our power rule. The integral of 1 over u du is ln absolute value of u. And of course, the key thing here is where is the u? Because if you're going to use substitution, here your u would be the base, here your u would be the denominator, here and here your u would be the exponent. When it gets to trig, of course, you have this possibility where u could be the angle, u could be the entire trig function. These next few formulas, you should remember, the integral of sine u is negative cosine u because the derivative of cosine u is negative sine u. Since the derivative of sine u is cosine u, the integral of cosine u is sine u. Now this one's a little trickier. If you remember, if you forget how to get to this formula, you could let tan u equal sine over cosine, letting your v, let's say, equal cosine u. That would mean that your derivative of your v would be negative sine u, and that's where the negative comes into play because you have to introduce and counteract. And then you'd end up with 1 over v dv, and the integral of that would be ln absolute value of v. But there is another version of this, and the other version of this is allowing the negative multiplier in front by the logarithmic rules to become the exponent. This is not inverse cosine, by the way, and that becomes 1 over cosine, which is actually ln absolute value of secant. Coming back up over here, same idea. If you were to let cotan u be cos u over sine u, your denominator would be your v, the derivative would be your cosine u du on top, and therefore you'd have 1 over v, integral of 1 over v dv, which would be ln absolute value of v. Again, integral of secant, integral of cosecant. This probably looks more familiar to you. They are the same formula. Derivative of tan is secant squared. Derivative of cotan is negative cosecant squared. Derivative of secant is secant tan. Derivative of cosecant is negative cosecant cotan. Now the last ones are the hardest ones. These are the ones involving inverse trig. So the first thing to notice is that for numbers 18 and 20, you are dealing with the denominator of a square root of either a constant squared minus a function squared or a function squared minus a constant squared. Also, the giveaway that it's an arcsecant is that there's this extra u on the outside. The key thing here that you need to understand is this du is the derivative of u, not the derivative of u squared. The other thing to be careful of course, is the fact that in these formulas, the arc sign does not have a 1 over a in front of it. So if we look at these three examples from the book, examples 1a, b, and c, you'll notice all denominators are equal. The difference is in the numerators. That one is 4, that one's 4x, that one's 4x squared. As it turns out, the middle one is actually the easiest one because here we're able to say let u equal x squared plus 9, the derivative would be 2x dx. So here's the x that we need. However, over here, if we let u equal x squared plus 9, we do not have a numerator that has an x in it. So again, hopefully you'll recognize the sum of two squares. You'll think of arctan. If u squared is x squared, u is x, so du sure enough is dx. If a squared is 9, a is 3. And here's the formula. They pull out the 4, and then there's your 1 over a inverse tan of u over a. Part B, of course, is the easiest one. You simply let u equal the denominator. The derivative of that denominator is 2x dx. Now, what they did is they took the 4x dx and separated it into 2 times 2x dx. You could have pulled the 4 on the outside, introduced the 2 that you need for the du, and counteract with the half. You'll get the same thing. You end up with 2 times the integral of du over u, or 1 over u du, which is 2 times the ln of the absolute value of u plus c. And do keep in mind, first of all, make sure that you have the absolute values. Make sure you don't leave your answer in terms of u when the question was in terms of x. Substitute, and you don't need the absolute values here because that's always positive. The next one, of course, hopefully you'll notice is a dolly. Degree of the top equals the degree of the bottom. And the first thing they do is the division, which they don't show you. So here's the long division down here. Here's the quotient. Here's the remainder. There's the divisor. So you have the quotient plus the remainder, which is negative 36, over the divisor, which is x squared plus 9. They split that up. And again, we have an arctan. U squared is x squared. U is equal to x. Du is dx. And a squared is 9, so a is 3. And we will stop right now and go on to the second one after this.